Hi, students. We're going to look at VSEPR. You're going to be given a packet that has the steps for doing VSEPR drawings, which is what we do for covalent compounds. But I'm going to demonstrate all those steps here, and that's why I just want you to put those steps to the side and know you have them, but you will need your VSEPR chart. Okay, so be sure you have that part out from those notes. All right, to draw a shape for covalent compounds that we can look up and go three-dimensional is what we're going to do. And we start always with totaling the valence electrons. So these are the dots from dot diagrams, the valence electrons, and we're going to total them all up. So carbon, everything in carbon's group has 4 valence electrons. Chlorine, everything in chlorine's group has 7. And there's 4 of them. Now, I like to show that I have 4 7s. You can add it all up if you want. Just be careful. For me, it's a great way to check my work to be able to see I have 4 7s accounted for there. Okay, so the total here is 32. Now, in our drawings, our electrons are always going to be paired up, whether it's a bonding pair or a lone pair, always going to be pairs. So we're going to divide by 2 to begin with and just make it easier on ourselves. We'll have 1 atom in the center, and it's pretty obvious. I'm going to have like the carbon in the center and 4 chlorines going around it. If it's not obvious, 2 rules. Hydrogen can never be in the middle, and the least electronegative will be in the middle. Now, by least, remember, fluorine's the most. So the farthest away from fluorine on the periodic table, it goes in the middle, right? Again, hydrogen can never go in the middle. Don't put hydrogen in the middle. Okay, so I'm going to put carbon in the middle. I'm just going to draw 4 bonds to attach 4 chlorines because that has to happen. Okay. So step 1, we put the inside bonds. It has to hold together with those. You have to put them, okay? Step 2, we're going to put the outside lone pairs. All atoms that are not hydrogen always get these 3 lone pairs on the outside. Hydrogen does not get any. It's the only exception. Every other element, when it's an outside atom, not an inside atom like the carbon, on the outside gets 3 lone pairs. Okay, so each of the 2 dots counts as a pair, and each of these lines count as a pair. So now that I've done steps 1 and 2, I've put my inside bonds that hold everything together. I've put my lone pairs around all the outside atoms. I'm going to count my pairs. 1, 2, 3, 4, 5, 6, 7, 8. It's hard to see. Okay, so 5, 6, 7, 8. Those 2 go together there. 9, 10, 11, 12, 13, 14, 15, 16. So I needed to show 16 pairs. I am showing 16 pairs. My drawing is good. My drawing is not 3-dimensional. It doesn't have to be. The whole point of our VSEPR chart is that we use the information from our quick little sketch that's 2-dimensional to find what the 3-dimensional information would be. So Ca is connected atoms. How many atoms are connected to carbon? Well, 4. How many lone pairs, now be careful, lone pairs on the center atom, how many lone pairs are connected to carbon? 0. I'm not counting those on the outside. Not doing it. Don't count them. Okay, Ca is connected atoms to the central atom. LP is lone pairs on the central atom. And then electron domains, ED, is the total. You literally just add your Ca and LP together. Now I find that combination on the chart, and there's only 1 row on the chart here that's going to be a 404. It's that easy. And I look up what the EG is, and that is tetrahedral. And I look up what the Mg is, and that is tetrahedral. And I have no idea why that just moved on me, but it will. Okay. And you even have a 3-dimensional picture here showing what it could look like 3-dimensionally speaking. Our sketch isn't 3-dimensional, so it's no good to begin with. So don't worry. Don't worry if your sketch doesn't look like the picture. It doesn't have to. Your sketch needs to be good enough to get your Ca, Lp, and Ed so you can get your Eg and Mg. That's all your sketch needs to do. So not that difficult going on there. Okay, let's scroll a little more here. Okay, I'm going to pick a new color. Let's go blue. Blue sounds fun. Okay. So H2O, each hydrogen is 1 because they're in group 1A, right? 1 valence electron. Oxygen is in group 6A or 16. It has 6 valence electrons. That's 8. Pair them up 4. These steps are always the same. I always want pairs. Now, hydrogen can never be in the middle, so it's got to be the oxygen. And I'm going to stick a hydrogen there, and I'm going to stick a hydrogen there because they've got to hold together somehow. So I have drawn 1, 2 pairs, 2 bonding pairs of my 4. Okay, now I would do step 2 where I'd put lone pairs on the outside, but hydrogen never gets any lone pairs. So that step's done. I don't need to do that step. Okay, next one I'm going to do is to put the leftover. Okay, I'm using 2, so imagine go -2. The leftovers, if you have leftovers, the leftovers are lone pairs on the center atom. So something like that. All right. So this is the way I'm just going to quickly sketch it. It doesn't have to be 3-dimensional. You're not expected to know ahead of time what it's going to look like. But let's count my connected atoms. I have 2 connected atoms. I've got the hydrogens as connected atoms too. Lone pairs, I do have lone pairs this time. These 2 lone pairs on the oxygen, the center atom, is what I'm calculating. And I add that up for grand total. Wow, I don't know why I put 0. Let me try again, 2. I'm going to add that up for a grand total of 4. And now I'm going to go to my chart. And I'm going to look for a 2-2-4 combination. There's only one row that will be a 2-2-4 combination. You did it wrong if it doesn't match just one row. If you don't match any row, you did it wrong. Go back and count again. It's that easy. Okay. My electron geometry is still tetrahedral, but my molecular geometry is bent. And notice, the way I sketched it makes it look linear. We're never, ever, ever going to go off our sketch because your sketch is just a sketch. If you could somehow picture this in your mind and find the right picture ahead of time, you could draw it the way it should be drawn according to the picture, but you don't have to do that. Your sketch is just to get you to the point where you have the correct information. So it's okay, but do not trust your sketch to give you the EG and the MG. Don't do that. All right, thank you. Okay, I've got CO2. I'm going to get a new color here. Let's go for a green. I said go for a green. And I have carbon is a 4, each oxygen is a 6. And again, I'm getting those from the periodic table, those dot diagram amount of dots. That's all I'm counting, those valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Across the top of the tall rows of the periodic table. Add this all up, I get 16. We're going to pair them up. That's 8. So I've got carbon. It's going to hold to 2 oxygens. And there we go. There's the steps I've done so far. And I counted all up. 1, 2, 3, 4, 5, 6, 7, 8. And I have 8 pairs shown. I'm not done. Okay. I want to introduce you to a concept, and that is to beware for the synapse elements. These 5 elements, only these 5. These 5 elements, C, carbon, nitrogen, oxygen, phosphorus, sulfur, synapse. When they're the center atom, not the outside ones, when they're the center atoms, they must achieve an octet. That means 4 pairs around them. Now check this out. Earlier, we already had carbon, and carbon had 2, 4, 6, 8. So it already had an octet. I didn't have to worry about it with this one. Check out oxygen from earlier. Oxygen's a synapse element. It has 2, 4, 6, 8. Okay, I didn't have to worry about it earlier. But now check out my carbon now. Okay, it only has 2, 4. That's all I've got. I need it to have 8. It must have 8. So here's what we do. We grab an eraser, and I erase a lone pair off the outside atom that is also synops. Okay, this only happens between synops elements, and I'll make it a double bond. And now I'm closer. I have 2, 4, 6 electrons, 3 pairs. I need another pair. Now we could erase from this oxygen here, but we're not going to. We're going to erase from this oxygen here because nature has shown it would much rather have 2 double bonds than 1 triple and 1 single. Okay, so 2 double bonds giving that carbon an octet. So anytime one of these 5 are in the middle, you want to check to make sure it has an octet. It has 4 pairs. I had that in the first 2. It's going back up. I had that here and I had that here. I didn't have to worry about that here. But now here, I have to worry about it because I did not have that. So you always find the other synops elements that are on the outside, and you erase a lone pair and make a double bond, and you do it one at a time. Now let's check out this next one because the good news is we're going to have more synops practice here. Let's try this color. I like this color, whatever it's called. Okay, so hydrogen is 1. Carbon has 4 valence electrons, 4 dots. Nitrogen has 5 dots in its dot diagram. That's 10. I have 5 in total. Now, hydrogen cannot be in the middle. So it's between carbon and nitrogen. Carbon's the least electronegative. It's literally farthest from fluorine on the periodic table. So I'm going to use carbon. I'm going to connect hydrogen. I'm going to connect nitrogen. Okay? Now, so far I've used 2 of my 5, but I go on to this not hydrogen element, and I put the lone pairs. Now notice hydrogen does not get lone pairs ever, 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 ever. Okay, reminder, hydrogen is a 1s element. It can only hold 2 electrons total, and that is exactly what a bond gives it. That bond fills up hydrogen, has no room, cannot hold on to lone pairs. But nitrogen most certainly can. Okay, so with that said, oh, look, I have a synops element in the middle. It happens to be carbon again. It could be any of these 5. I have a synops element in the middle. Does it have an octet? It has 2, 4. So the short answer is no, it does not have an octet. We need to fix that, okay? So we're going to erase a lone pair on nitrogen, and we're going to make another bond. And now I have a single and a double, and that's 2, 4, 6. Oh, I'm closer. I've got 6, but I need 8. So I can't do it with hydrogen. Hydrogen's not part of synops. Can't do it with hydrogen. So I'm going to erase again from nitrogen. And again, I'm going to put another bond there, and now it's a triple bond. It can happen. No such thing as a quadruple bond. It stops at triple. You'd be able to tell me why after all of our VSEPR work. But anyway, 2, 4, 6, 8. I have my 8 pairs around carbon. Carbon has its octet. It's a synops element. I had to be sure that happened. It has happened. We're good to go. So this is the way this should look. Carbon with a single bond to hydrogen and triple bond to nitrogen. Now let's find what it would be called three-dimensionally. My connected atoms is 2, the hydrogen and the nitrogen. It's 2, that easy, okay? My lone pairs on the center atom on the carbon is 0. So 2 plus 0 is 2. It's that easy. Don't mess it up. Don't make it more complicated, okay? Find a 2, 0, 2 combination. You'll find only one row. It is called a linear and a linear. And I know the picture doesn't make it look like there's a double or triple bond, and it doesn't have to. Okay. And I just realized I didn't complete the last one. I got so excited about this triple bond, I didn't complete this last one. Let's complete this last one. It is also a 2, 0, 2. Okay. 2 oxygens, 0 lone pairs on the carbon in the middle. Totals up to 2. It's linear and linear. So these shapes don't know whether it's a single, double, or triple bond, and they don't care whether it's single, double, or triple bond. Your chart will be useful regardless. It is up to you to notice, is it part of synops? And only if it's part of synops might it have a double or triple bond. You don't know till you try. So beware the synops. Okay, 4 more examples, and we will then get to practice time. I'm going to try orange. Boron is a 3. Each fluorine's a 7. And again, I like to write them out so I can visibly see I have 3 7s. So that's 24, 12 pairs. Let's do boron and like maybe 3 fluor. It wouldn't matter. You could make them all the same on the same side. Your sketch is going to suck to begin with. It's not 3-dimensional. So don't sweat your sketch. Just do it well. Okay. So I've got 3 bonding pairs of my 12. I'm going to always do this. You should always have electrons enough to do this. The only time you don't do this is if they are hydrogen. Now I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs, 12 pairs. I'm done. I've got no leftovers. Nothing goes in the middle. Is boron part? Boron doesn't have an octet. It only has 6. Doesn't have 8. Is it part of synops? It is not. So I don't do anything with it. I'm done. I have 3 connected atoms, 0 lone pairs on the boron. Total is 3, 3, 0, 3. Trigonal, planar. And I have no idea why my G dropped down. Oh, now the whole word is, yay. Okay, I give up. And then the Mg is also trigonal planar. You'll notice that they are Eg and Mg are the same if there's no lone pairs on the center atom. That's the only time that they become different. Okay, let's move on. I'm going to pick, I don't know, let's try gold or whatever this color is, sand, brown, sparkles, whatever. Nitrogen is 5. Each hydrogen is 1. I like the visibility of seeing 3 1s. Okay, so that is 8, 4 pairs. Nitrogen in the middle because hydrogen cannot be. I think I have 3 hydrogens, so I'm going to go kind of like that. Now, hydrogen does not get any lone pairs, never lone pairs on hydrogen. And I count my pairs. 1, 2, 3 pairs. I need to show 4. Oh, I have leftovers. Okay. Leftovers are lone pairs on the center atom. That easy. Okay, nitrogen is synops. Does it have an octet? 2, 4, 6, 8. Yes, it does. I'm done with it. I don't need to worry about bonding more. The central atoms is 3. I have 3 hydrogens. Wow, connected atoms. 3 hydrogens connected. My lone pairs, I have 1 lone pair on the nitrogen. It only counts if they're on that center atom, that one there. Okay, so that's a total of 4. 3, 1, 4, we're going to look it up. Eg is tetrahedral. And the Mg is called trigonal pyramidal. It literally would stand up looking like a pyramid that has a triangle at the bottom. Not like the pyramids in Egypt. Those have squares at the bottom. This was trigonal pyramidal. It has a triangle base. Okay. Moving on, not so fast. Let's try another one. Let's try this bluey, turquoisey thing here. Carbon has 4. Each hydrogen has 1. Each chlorine has 7. And again, I like the visibility of seeing 3 7s because I have 3 chlorines. So let's see, 21, 22, 26. So I need to show 13 pairs. Okay, what goes in the middle? Least electronegative cannot be hydrogen. Don't do hydrogen. Big red X. Don't do hydrogen in the middle. Never, ever, ever hydrogen in the middle. Carbon in the middle. Ooh, synops. I will need to check that at the end. Let's kind of do this sort of thing where I've got some chlorines going on here. And I've got a hydrogen there. So 1 hydrogen, 3 chlorines. Hey, that's cool. I'm using up 4 pairs, but I'm not going to stop there. I'm automatically going to put the lone pairs on the chlorine. All right. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pairs. I have 13 pairs. I'm done. I'm out of pairs. That's my drawing. Checks to see if carbon has 8. 2, 4, 6, 8. It has its octet. I don't need to worry about it being synops. I'm done. 4 connected atoms. 0 of them are lone pairs on the carbon. I'm only looking at that carbon, right? Right? Yes, of course. So 4 in total. That's tetrahedral and tetrahedral. And my drawing makes it look like an X shape, and it is so not an X shape. You can see by this three-dimensional looking picture here. Tetrahedral is going to kind of look like a pyramid, like 3 down, 1 up, but no matter which way you rotate it, it's going to be symmetrical. So it's a 4-sided figure, all of them congruent. So tetrahedral. Okay, the last one we're going to do, we're going to do an SO2. And let's give this red stuff here a try and see what happens. Sulfur is 6. Each oxygen is 6. So that's 18. I'm going to have 9 pairs to show. Sulfur in the middle. And this one's kind of tricky. So just take my word for it. Sulfur is lower in electronegativity than oxygen. It is the way it goes. Okay. 2 oxygens. So I've got oxygen there, I've got oxygen there. And I'm going to lone pair those outside oxygens because I have to. So I might as well do them. There we go. Now count my pairs. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I have 8. I need 9. I have a leftover. Boom. But what do I notice? I notice that sulfur is synops. I want to check that it has 8. It has 2, 4, 6. So I need more, but I only need 1 more pair more. So I'm going to come up and grab my eraser, and I feel like this oxygen on the left. It would not matter. And then, boom, there we go. I don't know why that was suddenly so red looking. That is weird. Okay, that seems better. There we go. Okay, so there we go. I have a double bond, a single bond, and a lone pair on that sulfur. Now I'm not gonna do it on both sides. I've reached the octet. I'm done. I'm stepping away from it. Okay, not going to do more. We don't go past an octet. We just make sure these 5 get an octet, 8 electrons. A bond is a pair, that's 2. A lone pair is a pair, that's 2. It all counts. All right, so on the center atom, I have 2 atoms connected. Yeah, one's a double bond, one's a single bond, but VSEPR doesn't care. I have 1 lone pair, a 2, 1, 3 combinations. When I'm going to look up, I just add those down. So we see that the electron geometry is trigonal planar. So this would be a flat triangle. If I was trying to draw it 3-dimensionally, it would look something like that. So you see that triangle shape, and it doesn't matter whether you see it or not. You're just looking from the chart. And then the molecular geometry of 2, 1, 3, now I have that lone pair in there. That makes it different than before, so bent. All right, that's all there is to VSEPR. It really is totally dependent on the chart, so be sure you have your chart and keep it safe. You're not expected to memorize any of this. You're just expected to work it out each time. Watch out for those synops elements, okay? Remember that both the lines for bonds and the lone pairs, those all count as pairs. So we've been working with pairs this whole time. All right. And that's all there is to it. You just follow these steps that I've done over and over and over again, and then that's all there is to VSEPR. All right. So good luck. You have an assignment to complete now.